All right, so this is a quick little video about determining if a given factor is a factor of a polynomial. And so I just want to relate this real quick to quadratics. With a quadratic or a parabola, many times we factor these to help us find the x-intercepts. And so if we set this equal to 0 and we factor this quadratic, we can quickly see that x times x is x squared and 5 times 6 is 30. And if we have a negative 6 and a positive 5, then we can get our negative x in the middle. Now, we go ahead and to find our x-intercepts, we solve those sets of parentheses for 0, and so x equals 6 and x equals negative 5. Now, the importance of this is that I now know that when I graph my equation, that we are going to see at negative 6 and negative 5, we have x-intercepts. So x squared minus x minus 30. We hit graph, and we should see that our graph crosses at negative 5 and 6. We can also verify this by hitting second graph and looking at the table and seeing that at 6 we get 0 for our y, and if we scroll up the table to the negatives, we see at negative 5 we also get 0. And so the reason why I bring this up is that we're now going to be asked in this next problem, is n minus 7 a factor? Just like I could ask you, is x minus 6 a factor? And we could quickly determine if x minus 6 is a factor by checking and seeing if 6 gives us a 0 in our quadratic. Just as if I asked if x plus 5 was a factor, we could check if negative 5 gives us a 0 in our quadratic. And so that's simply what we're going to do. We're just going to take our factor and set it equal to 0. So n minus 7 equals 0, meaning that n equals 7 should give us a 0 if n minus 7 is a factor. So we'll go back to the calculator, and second mode takes us out back to our regular window. And so now we're going to plug 7 in for all the n's in our equation. And so 7 raised to the 4th plus 2 times 7 raised to the 3rd minus 64 times 7 raised to the 2 plus 15 times 7 minus 56. And when we punch that in, we quickly see that we get a 0. We could look at this in a graph, but we're going to have to do some adjusting of our window, and I don't want to go into that too much at the moment. But you can quickly plug it in your calculator, and we see that n minus 7 is a factor because 7 does make our equation equal to 0. And so we can answer yes to this question. N minus 7 is a factor. All right, let's do one more example. And so we see here that our divisor is 2r plus 2, so 2r plus 2 equals 0. Most of you can probably tell this is already negative 1, but if you couldn't, we can solve this for r, and when we divide by 2, we get r equals negative 1. And so we're going to substitute a negative 1 in for all the r's in our polynomial. So 6 times negative 1. Make sure you punch the negative button instead of the negative key instead of the minus. All right, plus 2 times negative 1 raised to the 2 plus 2 times negative 1 plus 5. And we check and we get negative 1. This means that we have a remainder of negative 1, and so 2r plus 2 is not a factor. And if you remember, if you checked out my last video over polynomial division, this here tells us that we would have a remainder of -1 when we divide by 2r plus 2. So let's just check that out real quick. And we'll just note we should have a remainder of -1. So r equals -1. So let's just go back over that polynomial division real quick. We want 2r plus 2 on the side, and a 6r cubed goes in the first column. And we need to figure out what times 2r is 6r cubed, and that would be 3r squared. And so in our bottom box, we get a 6r squared. Our next term in our polynomial is 2r squared, and so we want this diagonal here in green to give us another 2r squared. And so we're actually going to need a -4r squared to give us a 2r squared. And then 2r times what is -4r squared, and that would be a -2r, and -2r times 2 is -4r. Our next term is a 6r, and so let's highlight that. We'll go yellow. And so we want this next term to give us a 2r, and since we're in the negatives, we need a positive number. And so we're going to need a 6r with the -4r to give us a 2r, and 2r times 3 is 6r, and 3 times 2 is 6. Our next term in our polynomial is 5. And so to get a 5 here, we need a -1, which, because we plugged in the 0 for this in the beginning, we know that the remainder of -1 is appropriate. I'll just note that it's just coincidental that r equaled -1 as a 0 here, and that the remainder was -1. That is a coincidence. That does not always happen. And again, to write our answer down, we would have 3r squared minus 2r plus 3 minus, because the remainder was -1, and we put 1 over our divisor, which was 2r plus 2. If some of you feel comfortable, and I know that sometimes students struggle with this, if you want to write 3r squared minus 2r plus 3, and then you write plus, just note that you're going to have to put a -1 over 2r plus 2. So the negative can go out front, or you can put a -1 on top of the fraction and use a plus sign at the end. Either one of these would be considered a correct answer. And again, we didn't have to go through all that work. I just wanted to show you the connection between polynomial division with the remainder and checking to see if a factor is a factor of your polynomial. All right, guys, hope this helps.